extension number 4. We're going to try to summarize all the stuff we've learned and apply it to solving problems with these different types of objects. So with the rectangular prism, I hope you remember what the surface area was. Yes, it's just the area of all the surfaces. So there's a top and the bottom, right? So 2 of the top and the bottoms. And then, of course, 2 of the front and the back. And then, of course, 2 of the sides, right? So 2 of the bottoms would be what? Length times width. 2 at the front and back would be length times height. And 2 of the side would be the width times height. And volume, yeah, it's just length times width times height. Good. Remember the idea of a square base pyramid? Got the base area along with 4 of those triangular lateral sides. So B squared would be the base area. And those 4 triangles, so 4 times the base times the slanted height divided by 2. Or that simplifies to, I guess, 2BS. And the volume, yeah, remember that 1/3 thing where we have the water being filled into the rectangular prism? It took 3 of them, so that's why the square base is 1/3. Okay. A cylinder from grade 8, remember the surface area is the 2 circles plus the lateral side. And that would be 2 pi r8 squared. Plus 2 pi RH. Its volume, pi r squared h. And then we have the cone, yeah, where, once again, whoops, base area plus lateral side. And that had the formula pi r squared plus pi rs. For its volume was just 1/3 of the cylinder's volume, so 1/3 pi r squared h. And finally with the sphere, remember the oranges and the 4 circles for the surface area, 4 pi r squared. And then 4/3 pi r cubed for the volume. Now, today, we're going to be asked to find the surface area and volume of what they call composite objects. That's when you have more than one stuck together. And these objects are created by us, of combining maybe more than one or even 2 or more distinct objects. And you're going to put them together. So, to find the surface area composite object, it's not that hard. It's really just to find all the faces that make up the surface area of the entire composite object, right? Calculate the area of each of the faces, and then add them all up. That's it. Okay. Calculate the volume of the composite object. Well, identify all the distinct objects, like separate them. Calculate the volume of each, and then, yeah, add the volumes together. All right? So with these principles in mind, I think we can go about actually solving the questions. Let's turn the page. Here are 2. So I'd like you to find the surface area and the volume of these composites. Oops, something got missed there. Composite objects. And then round your answers to 2 decimal places. Okay. So for the surface area of this, notice that this is kind of like a house. There is a bottom base, right? So there's a hidden base down here. We gotta figure out that. So there's a base. What else is there? Oh, right. We also have the side walls, right? With the base, we have to add to it the side walls of the rectangular prism. So that's these pieces here, right? Like the one that's shaded in brown. And then what else is there? Ah, yes. Don't forget the triangular pieces. The triangular pieces, right, that make up like the roof. So we can figure out all that, we'll be good. So let's see, the base is a square, so 24 times 24, that's the base. the side walls, notice they're rectangles, so 24 times 8. How many side walls do we have, and are they all the same thing? Yes, they are. So there are 4 of them. And then now we need the triangular pieces. And the triangular pieces here, well, let's see. We have the base. But do we have the slanted height? Uh-oh. We actually don't have that. So that's going to be a problem. How can we figure out that slanted height? If you thought about Pythagoras, once again, Pythagoras to the rescue. 5. I need my slanted height. And then that length here to the center, to the edge of the, I guess the square base there, I believe that equals to 12, because it's half of 24. Knowing that, we can then use Pythagoras, and we find, I think, that the side length is 13. Nice. So that helps, because now we should be able to find the area of each of these triangular pieces. The base is 24. The slanted height now is 13, and we can divide that by 2. But don't forget there are 4 triangular pieces that are the same. So if we can do all these calculations, we will find the surface area. 24 squared, that's 576. 4 times 24 times 8. I think that's 768. And that's, let's see, 4 times 24 times 13 divided by 2. Ooh, I think that's 624. Okay? And put them all together. Ding! 1,968 feet squared. And that, my friends, is the surface area of this object. Okay? Now, we should also do the volume. And the volume then will be just looking at the 2 shapes separately. So look at the rectangular prism. And add to that the pyramid. So the volume of the prism is just length times width times height. So that's 24 times 24 times 8. That's easy. And the pyramid, that formula, 1/3 of the base area. The base area, of course, being the square, multiplied by the height to the center of the base, which is 5. I think volume is actually much more straightforward, right, than surface area. But in any case, there we go. Here is our solution. Okay. So that's part A, and part B is pretty much done the same kind of way. So I'm going to let you try part B, because I can't do it all for you. That's not fun. And let's see if you can go ahead and figure out how to do the surface area of the shape and the volume of the shape. Okay? Go. Once again, I'm thinking there's the bottom, which is a rectangle, right? By the way, this here, this is a rectangular prism, if you can't see that. And the top is really like a half of a cylinder. So at the bottom. And then we have the front and the back of the rectangular prism. Then we have the sides, right? The 2 sides of the rectangular prism. And then what else do we have? Well, we've got that that curved part of the cylinder, right? So actually there's these 2 half circles first of all on the side. So maybe I'll say plus 2 half circles. And then along with that is the toughest part. That's this curved area here. I'll call it the curved part of the cylinder. Plus, and it's not the full curved part, but the half of the lateral surface area of the cylinder. Okay, so we have to calculate all these parts, and then we got to put them together. Okay, so being able to identify the parts actually helps, I think, quite a bit. Because now if I want the bottom of the box here is just 20 times 8, right? 20 times 8. The front and back would be 20 times 8, of course, again. But this time I have two of them, so I'll multiply by 2. The two side pieces are the shaded piece here, so 8 times 8, but once again there are two of them. And then now with the half circles, I've got two half circles, so half times pi r in this case. So what is r? If that's 8, that means it's 4, so 4 squared. And then the lateral surface, that's the 2 pi r h, and the h, of course, is the length, so it's 20. Okay, so this all added together is the surface area. 160, 320, 128. This part here, 2 times a half, that's just 1. 4 squared is 16, so 16 pi. And here, the half times 2 is just 1, so this is 80 pi. So if I want to put this together a little bit more, this would be what, 608 plus, I think, 96 pi. And if you wanted a nice decimal, then approximately 909.59 inches squared. If that's what you got, congratulations. But there's more. There's volume. So remember the volume, which is a little bit easier, is just the prism on the bottom plus half of the cylinder. So the prism on the bottom, once again, is just the base times the height times the width. And half of the cylinder, the cylinder is pi r, which is 4, squared h, which is 20. And then we can calculate that. That's what, 1,280 plus 160 pi. Or for those of you who like decimals, there you have it. Done. Okay. Alright, so we got one more and we're done today. Let's see what this says. Calculate the surface area of the greatest cube that could be placed inside a sphere with radius 15. And then it says, determine how many times greater is the surface area of the sphere than that of the cube. Well, I'm hoping you could kind of visualize what the diagonal of the cube will be. Remember, the cube is like this. There's a base diagonal, right? There is also a diagonal that goes from one edge to the other like this. And to calculate that, you see how it's like this, a right angle triangle. So I'm thinking if we call this S, S, and S, the diagonal of the base of the cube, which is, let's call it this distance here, well, that will just be S squared plus S squared with the square root. Yeah. But if I wanted to find the diagonal here, this larger one, this red one, well, that would be taking root S squared plus S squared, that's this piece. Gotta do this one here, which is another S squared plus S squared, and that is supposed to be equal to that red line, that diagonal squared. I forgot to square it, by the way. So really, what do we have here? I've got s squared plus s squared plus s squared equals to the diagonal squared. And so 3 of these s squareds equal to the diagonal squared. So if I want the diagonal by itself, that'll be the square root of 3s squared. And why would I even want the diagonal? Well, I want that because the diagonal of that cube just happens to be equal to the diameter of my sphere. So note, the diagonal of the cube is equal to the diameter of the sphere. So, what does that mean? Well, if I want it to be big, I need it to be like that. So, the diameter of the diagonal, which is root 3s squared, must be equal to, what is the diameter of the sphere? If the radius is 15, then the diameter is, that's right, 30. And if you needed to actually go ahead and solve for s now, because I will have to do that to find the surface area, we can go do that. Well, it's weird with the square root, right? So if I want to get rid of the square root, I need to now square both sides. So if I square both sides, I get this. 30 squared is 900. I can solve for s now. S squared equals to 300, or s equals to the square root of 300, or that's approximately 17.13. And this, of course, would be in centimeters. So this is helpful to us because now I can actually figure out the surface area of the cube. And then I can figure out the surface area of the sphere. And then I can actually answer the question of the ratio. So knowing s now, therefore, the surface area of the cube is equal to, 6 times each of those sides, which happen to be a square, which actually happens to be 6 times, if I wanted to be more accurate here, by the way, I can just say root 300 squared, which actually just becomes 6 times 300, or 1800. Cool. And then I can also find the surface area of the sphere, because now that I know r, I have here 4 pi, oh actually I didn't know r much earlier, 4 pi r squared. That just equals to 900 pi. And then finally, what was I asking for again? Oh right, it was the ratio. What is the ratio of what? The surface area of the sphere compared to the surface area of the cube. And I can just write this as the 900 over 1800. And notice that this simplifies to this lovely ratio of pi over 2. There you go.